Good morning, everyone. Welcome. I just wanted to make a quick announcement that we are going to start a few minutes late, so apologies for that. But we are there, we are starting soon, so please hold on.
Chiara is coming. Apologies.
Thank you, Tommaso.
Okay.
So perhaps we can start with some welcome in the meantime, and then I'm sure that Chiara will be here when it will be her turn to speak. So welcome again to this third webinar of the RethinkAction project and the integrated assessment platform of this project. I would like to start by actually giving the floor to Puria Saleh. He's the head of Urban Research, Innovation and Development team and the ICLEI World Secretariat. So Puria, over to you.
Thank you so much, Celine, and good morning, good afternoon, everyone. This is absolutely a pleasure to be with you today on the third and the last webinar from the capacity development webinar series on the Rethink Action project. Today is going to be very exciting for us, simply because we'll delve into more tangible sort of elements of this project and the Rethink Action platform. We are delivering today's webinar hand in hand with other partners of the Rethink Action Consortium. So we will begin the work in the presentation with our colleague Chiara from CMCC, who will introduce LAMS, and she'll walk all of us through the construction of the LAMS and presents the LAMS catalog. And following this, she'll also invite all of us, all the participants, to choose a specific LAM for a live walkthrough of the platform. This is cool, right? And then there will be a 10-minute segment for the independent exploration and Q&A, and that is your chance to ask any question that you may have. And then next, we'll move to our colleague, Tommaso Brazzini from UVA, who will present the scenario planning tools, which is another yet important component of this platform, following more or less a similar structure, platform walkthrough, interactive collaboration, and also a Q&A. So this will be really super useful to make sure we get all from these the experts here, from selecting and exploring them, so supporting evidence-based planning, impacts on different policy scenarios, interpret simulation outputs, and of course, exchange insights and experience. And then also, we all get to sort of understand the added value of integrated tools like the Rethink Action platform in the planning processes in our cities and jurisdictions. for us as ICLEI World Secretariat and ICLEI European Secretariat, who are leading on the delivery of this capacity building, it is really important to make sure that the tools that are developed by scientists will be actually usable with the cities and citizens in Europe and across the world. So as I mentioned, there will be these sort of two particular important segments of exploring LAMs and understanding scenario analysis with the Q&A and walkthrough through the platform. So we are looking forward to have you engaged throughout this webinar. Thank you so much for being with us, and please do share this platform and the learnings from this webinar with your colleagues across your city and across Europe. Thank you, and over to you, Celine.
Thank you, Puria. Okay, so I think I'm going to give you some housekeeping rules very quickly before diving into the content. So please, when you're not speaking, of course, keep your microphone on mute. If it would be very nice to see our faces here, so if you have a chance and the possibility, feel free to keep your camera on. Also, as Puria said, we want to hear from you, so you can use the chat that we have here in the webinars for the questions, along with some dedicated moment when we will ask you directly for some feedback on what we are doing today. And also we will be using Slido to collect your inputs on specific points. So I think that without further ado, we can start now. The first session would be exploring the LAMS catalog, the Land Use Based Adaptation and Mitigation Solutions catalog that the platform offers. And you will be guided into the exploring of this catalog and how to filter the option that is offered in the platform. And Chiara De Notaris, who's a scientist at the CMCC Foundation, will guide you through this part. So I will hand over to Chiara now, please. The floor is yours.
Yeah, thank you, Selene and Puria, for the introduction. And I'm sorry about my voice. I have a bit of a cold. So yeah, I'm Chiara De Notaris from the Euro-Mediterranean Center on Climate Change. We are based in Italy, and my group and I led the activity in relation to the identification of the land-based adaptation and mitigation solutions that are included in the RethinkAction catalog. So the idea of my session here is to give a bit of background on how the LAMs were identified and characterized, and how you can explore them in the Catalog Explorer tool in the platform. And then some of the solutions, some of the LAMs that we have explored a bit will also be simulated by Tommaso in the next session. So hopefully there will be a bit of a logical flow between the two parts. So LAMS stands for Land Use Based Adaptation and Mitigation Solutions. Based on previous work that was, for example, by the Intergovernmental Panel on Climate Change, we group them in three categories. There are spatial planning solutions, that are the solutions that affect the use of land and can potentially imply a change in land use. For example, the creation of protected areas or the conversion of cropland into grassland and afforestation. So there is a change in how the land is used. Then there are land management solutions, which imply a change in the management of a given land without the need to change the land use. So all the solutions that are related to agricultural management, for example. So it stays an agricultural site, but we change how the land is managed. And then there is another group of solutions that are the lifestyle behavioral change solutions, which require a change in the socioeconomic production and consumption patterns. For example, all the solutions that are related to dietary changes. To the next slide. So how did we identify these solutions? Because now I told you the main categories of the solutions, but what are the solutions? We started by studying. So we read several policy documents and at the European and global level, and also at the national level. And most importantly, I should say, the IPCC reports, especially the one, the 2019 report on land use and climate change. That was really the starting point for the identification of the solutions. And then we also had some consultations with stakeholders and experts. From our case studies on the solutions. And finally, so from all the process that then I will explain better in the next slide, we arrived to a catalog, to a list of 60 lands. These were characterized based on a set of specifications that again I will explain a bit more in depth later. And then all this information, so the list of lands and their characteristics, are in the LAMS catalog. This catalog is an Excel file that you can download from a link that I will give you in one of the next slides. And you can also just explore this catalog using the RethinkAction platform. To the next slide. So, as I said, we started from studying IPCC reports, more than 100 policy documents, including European and global and local national documents. And we extracted information on land-based solutions dealing with climate change, mitigation and adaptation from several sectors. So the focus is on land use, but several sectors are included. There's the agricultural sector, energy, industry, forestry, water and waste management. So all the sectors that are directly or indirectly related to land use were included in this analysis. And in the end, after several rounds of refinement, we arrived to a list of 60 LAMs that is a consolidated list. So all the information that were extracted was in most cases dealing with the same things, but just written in a different way. So we tried to consolidate as much as possible the information to arrive to a list of 60. To the next slide. And then the way we tried to characterize these solutions was by identifying some general specifications, again, like the sector that they deal with, but also the land cover type, the application, whether demand or supply, the scope, adaptation or mitigation, the scale, if it's only applicable at the local level or at the broader level, the actors involved, and the type of institutional support needed. And then a very important step was to identify the suitability factors, which are geographical, regulatory, sustainability, and techno-economic factors that influence the applicability of the solutions to a specific context. And these suitability factors were then used also for of the solutions and the identification of where they can be applied. And you can maybe recall, if you were there at the last webinar, that when exploring a case study, you could see which solutions were applicable where. And this is based on the suitability factors. And then we also specified the processes and the parameters involved in the implementation of the LAMs. For example, cover crops imply better recycling of nutrients in agricultural systems. So we expect that less fertilization is needed for the following crop. So this is the type of process that is involved in the application of a solution. And then all the other assumptions can be made. Then the adaptation and mitigation potential, I just want to say that I will come back to this because it's important to specify that adaptation and mitigation potential were assessed at a global level based on IPCC estimates. And I will give a bit more details about this later. And then drivers and barriers to the application of the solutions based on a literature review, synergies and trade-offs, KPIs and SDGs. And I will just give a few more details in the next slide. So the adaptation and mitigation potential, as I said, it's a general assessment. It was expressed in as it's expressed in IPCC reports. So it's a qualitative description mostly, so small, moderate, or large, with the respective intervals of confidence. When it comes to the mitigation potential, this qualitative description also corresponds to CO2 equivalents per year that can be saved, again, based on the estimates from IPCC reports. And when it comes to adaptation, we also try to identify the main risks addressed by the solution and possible opportunities associated to them. And this was done also to highlight the synergy between adaptation and mitigation, because for some of the mitigation solutions, we could also find some co-benefits in terms of adaptation. And then cost of implementation, again, was based on IPCC estimates. And when, in general, when data were not available, we reported that no global estimates were reported. So adaptation and mitigation potential is a general assessment. And then the next slide is the way synergies and trade-offs were assessed. And I just want to say that I want to explain these steps because you will find them in the platform. So one of the filtering options is this, resources and impacts. And it's important that you know what do they mean when you go in the platform and try to filter based on this. This type of assessment based on expert judgment. So all the partners in the RethinkAction project were involved in this assessment with an iterative process. So when a partner performed the assessment for a set of LAMs, then another partner redid the same assessment for 2 or 3 times. Now I don't remember. And then we merged the assessments made from different people from different backgrounds. So the idea was to have, yes, an expert judgment, but let's say validated by the iterative process. For the resources needed, it was the resources required for the LAMs to be implemented, including natural, social, economic, and financial resources, and the impacts where the impact that that solution can have on the environment, social impacts, economic and financial. And we were asked to rank or to give us, to impacts and resources, whether it was a positive impact or a negative impact, and a high or low level of resources needed for the implementation of the LAMs. And then we will see in the platform how this is represented. And then the next slide. Yeah, so as I said, the LAMs catalog is an Excel file that can be downloaded directly. So you can have access to all the information that I introduced here. There is a scientific publication on scientific data associated to the data set. So you're very welcome to go and check this out, and you will have access to the entire set of information. And then the next slide, is to go and explore a bit the catalog. You can choose now which solution you can choose between 4 options, which solutions you would like to explore further, and then we will do this exercise together in the platform.
I'm sorry to jump in. I think we are going to share now the codes on how to access the Slido in just a minute.
Yeah.
I don't think people attending has access yet, right? In the meantime, also welcome to the new people that have joined. We are now going through the a deep dive of the LAMS catalog of the RethinkAction platform, which is a catalog that has been put together and collecting more than 60 land use adaptation and mitigation solutions. Next step would be to have an interactive exploration of this catalog. And you will have now the possibility to choose which solution you're going to explore with Chiara. The codes, it's here, also the QR code. Thanks, Liam. Chiara, I will hand over to you again to
So
this.
just to say that I chose 4 lamps, 2 from the agricultural sector and 2 from the energy. This was because these 2 sectors are the main sectors covering lamps in the lamps catalog, and they are quite broadly applicable. So I expect that this might be relevant for most contexts. Okay, but we have, I think, a clear winner: solar panels in rooftops buildings. And then I think, if we have time, I can also go and show you cover crops or improved grazing land management. Okay, but now I will share my screen. I think you should be able to see it. It's the LAMS, the RethinkAction platform. I will log in with my credentials, and then let's say that I enter as a citizen. I will see 3 tools. There's the LAMS catalog, the local analysis, and the European global analysis. Today, I will focus on the LAMS catalog. So what you see is this visual representation, this flower representation of the solutions, where the yellow dots are the lamps. And then if I just condense the visualization, blue dots are the primary sectors. So as I said, it's land-based solutions, but related to several sectors. Now, I could try to find here in the energy sector my solution, just like checking it. Right. The other thing that I can do is to search for the lamps. Since, I'm just using a keyword, rooftop, and the dot where the lamps is nested, highlighted. So here it's solar panels in rooftops buildings, the lamps that I was looking for. And when I click on it, on the right panel, the main information about this solution appear. So a general description of the solution. What is solar panels in rooftops buildings as a solution? It's the generation of electricity from solar energy by installing photovoltaic panels on rooftops to meet land competing food energy demands in the urban context. Okay. What's the scale of application? It can be applied, of course, it's applied at the local scale, but policy-wise, it can be relevant at different scales. It's a spatial planning type of solution because it has implications on land use when the conversion land to scope is mitigation. And then we can find the contribution of these lands to the sustainable development goals. So this is very essential information. But then if I want to read more, I can download the fact sheet. Each of the solutions, each of the lamps has a fact sheet associated. Now it takes a little bit, but it should open soon. Yes. So the fact sheet contains more detailed information about the solution. Again, there is a general description, but now I can also see the type of land use, the policy sectors that are involved, the application, the mitigation potential. In this case, it's a large mitigation potential, the processes, effects, and relevant factors. It reduces the need for non-renewable energy, actors involved, and a small section on the benefits. So this is a more of a narrative part where the process is explained. And then there is a page dedicated to the explanation of co-benefits and possible negative effects, where you can find the assessment on impacts and resources requirements. So the part that I was introducing before with my slides. Here is the legend. So for the impacts, we have from positive impact to negative impact. For resources, we have high amount of resources to no resources needed. The drivers and barriers, or also in this case, organized by different types of drivers and barriers. And this was all based on a literature review. So all the references are found here with the numbers. And then in the last page, you find all the references. So the policy documents from which the solution was retrieved, and the scientific references that were used for the assessment of drivers and barriers, but also the mitigation potential. So this is what we can do by looking for specific lamps in the catalog. We can either look for it trying to find it, or just write a keyword. Now, if I try to write cover crops, you see now this dot became highlighted, and then I can find cover crops and find information on cover crops. And if I want, I can download the fact sheet about cover crops. from here as well. It takes a bit of time. But the other functionality that I wanted to show you is the filtering option, synergies and trade-offs. Again, this is based on the assessment of impacts and resources needed for the implementation of the solution. Decide if you want to filter based on the impacts or the resources needed. When you look for the impacts, you mostly deal with synergies. So if I want to find all the solutions that have a positive impact on greenhouse gas emission, in this case, it means that they reduce greenhouse gas emissions, I can filter and find all the lamps that have a positive impact on greenhouse gas emissions. If I want instead to look for trade-offs, for example, I could decide to filter based on the need for land. So if I want to find all the lamps that require a high amount of land, I will find, for example, increasing cultivated area, increased use of renewable energy sources in the transport sector, protecting and restoring wetlands and peatlands. So you see a possible trade-off here is protecting and restoring peatlands with increased in cultivated area. Land management of solar photovoltaic systems. Again, it could be a trade-off or a conflict between different land uses and so on. So this is the type of filtering that can be done in the catalog. And then the last filter is the C recommended lamps. With this filter, you can indicate what are your objectives and priorities. You can select some sectors and you can rank the objectives. So if your main objective is to save water resources, you can have this ranked as first. If your second objective is to ensure food security, you can bring it up and so on. And the same for the criteria that you want to use in selecting the solutions. For example, implementation cost maybe is your first criteria. And then the algorithm will show you which solutions are more relevant based on your priorities. And then you can explore them. So, for example, here I chose crop rotation with leguminous crops. And then you can find information and download the fact sheet and so on. So this is the catalog tool and how you can explore the land use based adaptation and mitigation solutions in the platform. And I think the next step is to give you a little bit of time to explore on your own the catalog. I don't know how much time we have left. I probably went a bit long.
It's okay. We are a little bit over time, but we might have, we need to have some minutes for participants to just go and explore. So Lian has just posted the link to the platform. So this is a moment when you can enter the platform, start looking what's there, and also feel free to engage. So ask questions, clarifications, unmute yourself, raise your virtual hands, whatever you prefer. But it would be good to have a little bit of feedback from you. So Chiara already explained what is this path of the lamps in the platform, and feel free to enter. You don't need to do the registration right now. If you don't want to, you can probably just enter as a guest, which is maybe the quickest option now, but then also enter in the way that you prefer, meaning on the role. You can be a citizen, a policymaker, an expert, and then explore the lamps. So I also would like to ask if anyone from the attendee also already have some questions, some things that you wanted to raise, have you managed to access the platform good? Also, again, we have the chat, the Q&A bits here in the meeting, so please feel free to share your view and inputs. Maybe we can also do something like that. Can you please give me a thumbs up if you managed to enter the platform? Nice. Great. So I guess you are also going through. I am looking through it at the moment. Thank you, Daniel. So I guess you already chose your role and you are in the LAMS catalog. So I will leave you just a few minutes. I will be silent, so you'll be free to share, to actually explore, and then I will come back to you in a couple of minutes. Just wondering how it's going. Don't be shy. Feel free to share any experience that you're having, if going through the catalog is user-friendly. What are you appreciating, or how, if you have any doubts on any points, please feel free to share.
Maybe if I can add one thing, I can see that maybe some of the participants here today are from very different contexts compared to the case studies that we have in RethinkAction. So we will see with Tommaso in the next session how to go through the local analysis. And some of you might think that this is not really relevant because the local context is very different. But this Catalog Explorer tool is actually the tool that is most applicable and replicable to very different contexts, again, because it's based on their general assessments, like the IPCC report on land use and climate change and the 6th assessment report. So in that sense, it can be applied to very different contexts, taking into account that then the local application might be different based on the context.
Thanks, Chiara. And also, maybe just as a quick reaction, a thumbs up would be nice if you have gone through the LAMS catalog already, if you feel that you have a fair idea of how it works, if you're done with it. It would be good. Otherwise, we will wait a couple of more minutes for you to complete the exploration. I'm aware that this could take a lot of time going through different LAMs, but the idea here is for you to explore how it works, the structure and everything. Explore maybe 1 or 2 LAMs to see if everything is okay, to give you an idea on how maybe you could, and if you could use some of these solutions and these features of the platform in your specific case, if you are from a different case studies, as Chiara was saying. So please, if you feel free to move on to the next step, or if you also have further questions beside this chat, we also have the same Slido as before. You can post an anonymous question if you prefer to do like that. So the link is active. Please feel free to do so as well. We would really appreciate an input from you at this point. Also, Sumaya, please, if you can go to the next slide. So I see in the Slido that we have a couple of questions. Maybe I can read them aloud and see if Chiara can address this. So the first one is, how did you decide on the classification and filtering criteria? Maybe not just Chiara, if other partners here want to jump in, please feel free to do so. So just repeat the question. How did you decide on the classification and filtering criteria?
So do you mean on the how did we assign each LAMS to a category, or how did we decide to use those type of categories? I will try to reply to both options. So the categories for the general for the specifications were identified based on the literature that we reviewed. So how the solutions were described in the policy documents was the starting point for deciding on the categories. So this classification in land management, behavioral change, and so on, these categories were mostly in accordance or in trying to be coherent with IPCC reports, for example. And then other types of categories were more related to policy documents. So this is the answer on how did we decide to have the type of specifications and the categories included. And then the filtering criteria, this was not only made by us at CMCC, it was also decided in connection with the partners that developed the platform and several consultations with case studies. So there were a few demonstrations of the platforms and the preliminary design of the Catalog Explorer tool were presented at meetings and discussed. So the criteria for the filtering were decided in a consultation process, let's say. And this part about the inputs and the resources and impacts was selected because, yeah, it's not that easy to identify synergies and trade-offs because it's very complicated as an assessment, but it is a very important thing to consider when planning land use and land management strategies. So yeah, we thought that that would be a relevant information, especially to policy.
Thanks, Chiara. And then maybe we can also respond quickly to the second question, which is what were the challenges you faced during the design and the construction of the LAMs? If it can be summarized, I don't know.
Well, I think the main challenge was the high volume of information to be processed and the fact that ideally it would have been nice to give a description, a characterization of each solution also at the local level, but that was virtually impossible because, yeah, every context is very different and yeah, not enough information is available and it would have been required a lot more work, which was not doable. So the characterization had to be general.
Thank you. I don't see any more questions in the chat, so maybe we can go ahead and pass to the second bit of this webinar. So thanks again, Chiara, for your presentation. And now we're going on to the using the scenario planning and how use that to guide local planning, local decision making. So we'll go through the impacts of the different policy scenarios on the territorial development, and we will learn how to interpret simulation output, exchange insights and experiences. So I will hand over now to Tommaso Brazzini. He's a senior researcher at the Group of Energy, Economy and System Dynamics at the University of Valladolid. If we can also move to the next slide so people know exactly. And then I will leave the floor to Tommaso.
Thank you very much, Selene. You can hear me, yeah?
Very well.
Great. Thank you very much. So I appreciate to have space to just give just a couple of things, not going too much into the detail, unfortunately, because there's not much time in the webinar, but at least to understand what we can do actually, what's the capacity of the platform. So I'm from the University of Valladolid, as Selene was saying, and we are an interdisciplinary group that work on mostly on system dynamics to create models that can actually see the interactions, let's say, between major sectors, which could be energy, could be economy, could be land use, it could be society in general, demography, and so on and so forth. So the interdisciplinarity is quite crucial for that. So let's in this very small talk, I will show a bit about what's a model, what's a system dynamic model, what's our system dynamic model for the local analysis, what's a scenario, and how can we interpret the results from simulation of specific scenarios. So let's go in the next slide. And okay, if you bear with me for a moment, let's take the model at first as a black box. So we have some input data and output data. Next slide, please. Generally, this integrated assessment model are regarded as like in this image taken from Camber Brief. We have a list of inputs on the left that will go into the model. Inside the model will do his own stuff with several different joined together blocks, let's call it. The blocks are generally called modules. And then you will have some outcomes. Depending on how the model is structured on the inside, and depending also on the techniques used to create this model, you have more or less interactions or more or less feedbacks, okay? So next, the group on the left is basically grouped as a scenario, which means that I have a set of assumptions that I will pass to the model, which might be GDP and GDP projection, population and population projections. We have some several other assumptions. It could be climate assumption, which is the assumption of the climate we are expecting for the future. And then within the scenario, there is all the list of policies that we would like to apply. Now, I'll bear with me and I'll explain you a bit, which is the connection between the policies and the lamps that we've been seeing right now with Chiara. So once I basically pass the input data as a group of data, policies, and so on, this is the scenario. This is one fixed scenario. The scenario will pass through the model, and we will get the outputs. Next, please. These are the outputs and indicators we're interested in. Okay, and that's more or less straightforward. Next, please. We know that models are not predictions for the future. That's really important because depending on how we take this, we might get one interpretation or the other. But we are very clear all the time that models do not make prediction. They actually simulate one specific scenario through what we called an exercise called what if exercise. What happens if I assume that there is a certain climate scenario, I assume a certain GDP projection and population projections, and I apply a certain type of policies with respect to what is called the baseline. We'll see later what is a baseline. So that's very important. So next, please. No, the other way around. Yes, that one. So now let's again, please, let's have a look at what's inside the SD model, because that's important to understand what do we mean. So in our system dynamic model, we have let's say 5 big blocks. We have land use block, the energy block, the water resources block, and then we have the GHG accounting and also a set of socioeconomic data. I say exogenous data because it was very challenging to create from local data the block for economy and demography. So we decided we would take the exogenous data, which means that we take some projection made from external sources, such as the World Bank or the national data and so on. So that's these are the main blocks. And next, and we would like to have certain input data, which are specifically climate scenario input, which means which is a scenario that I imagine for the future that I want to make the exercise on, and several other model input data. Now, I grouped it in model input data because there are so many input data related to the assumption on which is the amount of energy produced by a certain capacity, blah, 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 blah. So there are many parameters that are actually taken externally, but that are needed for making calculation and to see how the impacts between blocks and between the data and basically with time dependence. And then we have a set of policies, which are land use policies, mainly energy policies and water policies. Okay. Next, and then we will have exactly the outputs, and I've chosen here just a list of possible outputs, which could be how much food is produced through the land use, and mostly from cropland and grassland, which is the amount of renewable energy that we can produce if we put a certain type of policies, which is the amount of energy self-sufficiency, or basically how much energy I can actually cover with the produced energy internally. All the land use types, how do they change according to the policies, which is the amount of water consumed, the amount of water deficit, and so on. And then, of course, next we have connections. We will, I just draw a couple of lines because actually if I had to put all the lines, you wouldn't see anything. But mainly the input data will actually go into the several blocks. Actually, the blocks interact with each other, of course, because if you increase, for example, the energy production, then you will need some land to put some solar on it. So it's basically, and then if you next again, policies will affect the main module or the blocks we have here. The land use policy will affect land use, energy, and then water. And then lastly, we have the outputs that are coming from each of the modules. So I've created just a very easy sketch, but you can understand that this actually is full of arrows. Okay, so next, now I talked about policies, Chiara talked about LAMs. Mainly they are very similar, but LAMs are actually general assessment. They are designed to be informative and applicable mainly at all scales. But Chiara will correct me if I'm wrong, but it is generally something that is useful independently on the context. However, we are here using a model which is quite specific to a local context. So the policy implemented in the model have to be adapted to reflect basically the constraint and the availability of the data at local scale. So in some cases, a single lamp corresponds directly to a policy. The example is the rooftop photovoltaics that we've actually seen. In other cases, we needed to sum up some of the lamps to be able to model them. And the example here is, for example, the use of regenerative agriculture. We use regenerative agriculture as a policy, but it includes like cover crops, intercropping, and several others. For example, the rotation of the leguminous crops, and I don't remember which others, but I like 5 or 6, something like that. So, and yeah, and basically that's the main idea. So next slide. Okay, so model we have a typical structure of scenario. For example, scenario 1, we have a set of policy 1, policy 2, policy 3, and a set of assumption, similar to what I've said already. So what I'd like to do, if I have time, is to show you first scenario 1 in the platform and see what we get and how do we interpret the results. And then we will see if we change the scenario, what happens. So first of all, I need to share my screen, I suppose. Can I share my screen? Yeah.
Yes, I think you'll be able to do that.
Yeah. Can you see my screen?
Yes.
Okay, so let's start with scenario 1. Okay, we already have some results, but let's go, since the platform is under development, I just chose to just use some functionalities since they're not 100% working yet. So we look at things that we know that are perfectly working. So we have a list of outputs, which is what we're looking at right now. And for example, I've put the, let me check a moment. So I've decided to include regenerative agriculture. It's a policy. I activate the policy, and I put that 100% of the cropland is converting to regenerative agriculture. I put the year of application, it's 2030 until 2050. I save it, and then I put regenerative grazing on grassland, which is a typical technique that is used to improve the grazing practices in grassland. and I decided that it was 90%. The initial application in 2030 until 2050. Of course, a user can change all of this as much as he or she wants. And then I decided to add also solar on land, photovoltaics allocation on land. I activate the policy. I increase enormously the amount, like as if it was infinite, and I use the same years. Okay, and then I save. And for this, we've done the analysis into the Val d'Aosta region, which is in the northern Italy, which is one of our case studies. So the results that I see is, I always want to compare with baseline. Okay, I didn't say what is a baseline. Sorry about that. Baseline means it's a scenario without the application of any policy. So sorry about it, but that's basically it. So you don't apply any of the policies that I put right now, and you get the baseline. And while the simulated scenario is the scenario with all the policies that I've just added. In this case, there are 3. So what I wanted to see now is, for example, I included a lot of solar energy. Let's see what we have, the energy generation by primary type, for example. Okay, so this is the baseline. Okay, it's written here without the application of any policies. I do have in Val d'Aosta some solar. You can see it down below. Solar is 21 gigawatt year, wind, biomass, biogas, hydroelectric is 4,000 something, which is something that they already have without me applying it. Okay, but the solar is actually really small. However, if I start to increase the solar, I have this amount, which is roughly 16,000. Why it reached a point? I applied the policies from the year 2030 until 2050. But why it stops here? Simply because in the model we put limits due to the suitability of land and yeah, basically suitability of the land to include solar, basically to install ground-mounted solar photovoltaics. So when it reached that limit, it will stop. And then what happens? Then it will start to decrease because all energy actually has a lifetime. And so this curve follows the lifetime. I install as much as I can, and then it will start to decrease. However, on top of it, there is this hydroelectric, which is already present. I haven't put anything because it's already from historical, it's already in here. So that's the amount of basically gigawatt hour per year that I'll get by including these policies. So what if I want to see how much I'm producing compared to the demand? Then I have these two. I have the surplus and the deficit. So I will have a lot of surplus of electricity because the energy that actually the consumer can use is, we decided to divide it according to the IEA, International Energy Agency, into these 5 typology: solid, gases, liquids, heat, electricity. So the electricity is completely covered. Actually, we can export it if you want from in Val d'Aosta. And even in the case of the baseline, without the adding of solar PV, we still have a lot of electricity. However, if I see the deficit, all the other is actually in deficit. In both cases, actually, are the same because I've installed solar PV and I have hydroelectric. All of them will contribute to the electricity, not all the other things, which is solid, gases, liquid, and heat. I hope that is more or less clear. Then I want to see the land use effect of what of the policies I've put. And for example, I have the share of grassland and the regenerative grassland, what I was explaining before. I start the policy from 2030 until 2050, and then it will stay the same. Baseline, we don't have any. Okay, historically we don't see any. Okay, and this is all making year by year, is all making this calculation, and that I explained before, more or less. What happens with the regenerative agriculture? Same thing. We have the agriculture of all the products that we might produce from the land, and they will basically share the amount until I reach roughly 90%. Okay, so all the land products will be in regenerative agriculture. This might be wrong. As I said, the platform is under construction. And then I would like to show you carbon capture. The carbon capture due to regenerative grassland. That means that if I started to the practice of regenerative grazing, maybe you know it, but they will increase the carbon capture at soil level. So it will reach until 2050. Then most of the grassland will mature, and then there will be some bit of a declining. We can also have land use area, although here we'll see the changes are very small, but basically this is how the land use will change for each one of these types. Okay, generally are small because the changes in land use are we've seen even at the historical level, they don't change much, but the values are here. I don't know if I still have a little bit of time. I would like to try to show another scenario before.
Go ahead.
Okay, thanks. I think this. Okay. Scenario 2. Well, I add rooftop for the with the policies and configuration. Yes. So the other are all the same. We have photovoltaic allocation on land, and then I also added rooftop. I also put it the maximum, and basically I want to see if I can increase way more the energy production by adding rooftop PV, and maybe I can also, well, this can make me think if I have enough rooftop photovoltaics, then I can actually reduce the amount of photovoltaics on land to avoid the competition, for example. And so what I see, if I go now at the energy production by primary type, before I had roughly 16,000, now I have 17,000, compare with baseline always. So the amount of solar rooftop that I can take advantage of is relatively small to the total amount of solar. And that's already a good indication that will tell me, okay, I have limits. Yes, in the land use for ground-mounted solar PV, but I also have limited rooftop. Why? Because I have a limited amount of roof that I can take advantage of. Okay, and actually the model will calculate it. Okay, it will be a certain percentage of the rooftop area. It will calculate it and will give these values. Same thing, I can always see the energy surplus. Now the energy surplus is 70,000 terajoule per year. Before it was 66,000, so the difference is not that big, but we're still very high in the electricity compared to the demand of electricity locally. Okay, I think I just stop here and I'll wait for a question. Maybe it's better, and I think it's yeah. Can you hear me?
Yes.
Okay. I don't know how to stop sharing.
It's okay. I think that Jan already took over.
Okay.
Sorry. Yes, please. Any question, any doubt, please feel free to unmute yourself as usual, raise your virtual hand, type in the chat or in the Q&A dedicated section. But maybe what we can also do, Tommaso, if you agree, since now this last bit would be again a hands-on exploration of the platform. The participants have already in the chat the link again to the platform if they have closed it. But since we have missed how to get there, it would be good, and sorry for changing this last minute, maybe if you could share your screen again, Tommaso, and actually from the landing page of the platform having the path,
Sure.
how you get there, showing that this is a local analysis section. That would be great.
Okay.
So while Tommaso prepared this, so you were also able to see that, because some of these things we covered in the previous webinar, but you might not been there before. Maybe it's good. So you can do it at the same time if you have the possibility of having double screen or splitting your screen. And I will hand over to Tommaso again here just to show us how we get there.
Okay, so basically you enter or either as a guest or logging in, and then you click on local analysis. You choose one of the case studies that you're mostly interested into. And this is Val d'Aosta. Then to go to the local analysis, you have to skip all this part that we've seen already in the previous. And then you have to create a new scenario. So you create a new scenario. And then you make a scenario test. And then you can open this. You have to choose at least 4 sector. When you choose 4 sector, automatically the algorithm will give you the recommended lamps, which was what we've seen before with Chiara. Once it gives you the recommended lamps, and that's okay, but now we do something different. We save this part and we launch the model. So to launch the model, here you will have several sectors: water, agriculture, forest, energy, land and soil protection, behavior, and the assumptions. I haven't said anything before about the assumption because it was giving too many information, but here you can choose the future climate scenario, which we have calculated for SSP1 RCP 2.6, SSP2 RCP 4.5, SSP5 RCP 8.5. You can choose any of those and choose whichever policies you prefer. I was using the energy, rooftop photovoltaics, or photovoltaics on land, but you can also use wind farms deployment, hydropower deployment, float voltaics deployment, also the repowering part. And this, let's leave it aside for the moment. And then you have agriculture, this to increase the cropland rain-fed, increase the cropland irrigated, adding regenerative agriculture, adding precision agriculture, and here you can change the type of rain-fed crops or irrigated crops. Then you have afforestation, you increase the afforestation, you increase the forest plantation, and that's it. This is not working for the moment. And then you have the water part. Water part, unfortunately, is not completely functional yet. So there are platform is still under development, but to have a go to it, I think it's enough for now to understand how to interpret the results.
Thank you so much, Tommaso. I wonder if participants are in the platform, if you are exploring that part, if you have anything that you want to would like to share live with us, or maybe give us a reaction, a thumbs up, or anything to let us understand that you're there, that everything is fine, you're understanding everything. We know that this might be a lot, of course, but yeah, let's use these next few minutes ahead to explore this local analysis part. Also, as also Chiara was saying before, this of course has been built around data that is coming directly from the case studies that were involved in the project, but you might have already an idea or how to use that information to have a backup in for your reasons and for bringing forward some policies and new actions in your territory. Again, also we explained this in the second webinar, but you also for the local analysis path, you will have a way to select which case study is more relevant for you, which one is more similar to you, depending on different aspects and features that your territory has. So you can also do that, and I think on the landing page of the local analysis, you can also have access and clearly see where this quick questionnaire and survey is. So a lot of options are also available for persons and people not actually coming from those 6 case studies. But then maybe I see that also more questions are coming in. If anybody wants to intervene directly, we can maybe go through those one. So reading the first one, what lessons have you learned from this process that could inform the development of similar planning tools in the future? I don't know if Tommaso or any of the project partners that are here in the call would like to take this question.
Well, it's the first one. I mean, what lessons have you learned from this process that could inform development of planning tools in the future? Yeah, I can a bit try to say something here, at least from the model side, because actually the as you can see, the project was huge and several different tools have been developed. One of the learning from the modeling side is the difficulties of getting the best data that we need for the model. The local model are heavily reliant on the local data, and that's actually what you can see actually in the literature related to models, that the dependence on the data is quite crucial, not only to get the results and so on and so forth, but also and mostly to validate the model. If your model is not validated, mainly it's not that useful, I would say, because it would just make some calculation, but you're not sure if you can believe it. That's one of the critical issue in modeling. But that's just from my side and from the modeling part. Of course, there are other challenges, but I just leave maybe Chiara or somebody else to answer this.
Yeah, maybe I can just add, but it's also what I said before, that one big lesson learned for me and my team is that it can be difficult to retrieve enough information to feed models such as the one used in for the simulations at the local level, but also the global and European level. So it's really important to make sure that the input data that you provide to the model are valid and solid enough. And that can be challenging because sometimes you find 1-2 values from very specific contexts that cannot be generalized, and then you don't have enough data to support the simulations and to feed into the model. So maybe one lesson learned is that being ambitious is good, but sometimes it's also important to be realistic on what can be done based on the information that is available.
Thank you, Tommaso and Chiara. Not sure if we have other, and Tommaso cannot agree more. Okay, then the last question, and then we are going to the closing. At this point, I need to explore the catalog and platform, but it would be helpful to have a contact point for further details. The Rethink mail, okay, yes. It is, and of course, it's understandable. You can reach out to the Rethink Action email for any question you might have. Another thing that you might want to do also, if you want to have for us to have your contact, is also you can also fill these questionnaires this form we have created and is linked to the Rethink Action project website. There you would be among the persons that are going to explore further the platform, and you will have also through that direct connection with us. So please reach out, and we will try to give you as much information as possible for you to properly use the platform. Okay, looking at the time, I think we are going to the...
If I can add one thing just
Please,
quickly.
Tommaso.
If you go to the rethinkaction.eu, you can find actually the single person and in the team. So if you need some more specific message to somebody that has developed some specific thing, you can reach that person specifically.
Thanks, indeed. I just also copy pasted the web of the project. So thank you so much again, Tommaso. And I will now hand over to Purya again for the closing remarks.
Absolutely. Thank you so much, Celine, and thanks all the other colleagues for their input. I think, as Chiara mentioned, a lot of this work is rooted in the 2019 IPCC Special Report on Climate Change and Land Use and Land. And I think that's quite important because this shows that this platform is science-informed. I think we all can agree that IPCC reports are a solid assessment report to inform policy and practice. And that's what has exactly happened at the Rethink Action, right? So you're as a tool to transform the complex findings of that and other reports and knowledge products into actionable data. And as you saw today, interactive tools to support you in decision-making around that data. And as you can see, we have worked to provide a mix of data formats for the LAMS catalog. And I personally believe LAMS catalog is a very, very useful piece because this can be used also in other sort of initiatives. But you can sort of access them as a spreadsheet, an interactive visualization, and as fact sheets, as well as tools to evaluate the potential of those solutions in context. So we know running system dynamics models and simulations are not easy. We all gather that, Tommaso. But if you all didn't grasp it today, fear not. We are excited to share that we will be launching a massive online course, a free MOOC, to support you in using this methodology in your city or region in September. We hope that this will support your work wherever you are joining from to improve land use and land management and land use-based adaptation and mitigation measures to achieve your climate goals. And as the team has already said, please do not hesitate to reach out with any questions that you have, and keep an eye out for the MOOC that is forthcoming. Thank you from my end, and thank you for your engagement and participation, and I'm looking forward to making better decisions together for our cities. Thank you. Over to you, Celine.
Thank you, Purya. So now it's really all. Thank you so much for attending. Thanks to all the participants, and also on my behalf, I really hope to hear from you very soon. Have a nice day.